Hi friends, let us understand this concept where we have to do sum of products of some progression. Here we can see 1, 2, 3, these are in arithmetic progressions. Similarly, 2, 3, 4, they are also in arithmetic progressions. In this kind of problems, it is very easy. Here nth term is n into n plus 1, right? So first 1, 2, 3, 4, whatever, nth term will be n into n plus 1. So what is sum of n into n plus 1? So we just do this. N into n plus 1 is n square plus 1. Right. The sum of all of this. Now sum of n square plus n, we can do sum of n square plus sum of n. What is sum of n square? Which we have already proved n into n plus 1 into 2n plus 1 by 6. We already have a video around this. We already proved this. How we proved this. And how Gauss actually proved this. The great German scientist, German mathematician Gauss has done this at the age of at the age of 8 itself. When he was such a kid, he proved this. Similarly, we have also proved this also. Sum of n. This is also sum of n. This is also sum of n square. N into n plus 1 by 2. So the total sum is actually sum of this plus this, which becomes n into n plus 1 by 2. We are taking that common. So here we will be left with 2n plus 1 by 3. And here we will be left with nothing. Right? You'll be left with 1 only. So n into n plus 1 by 2 into 2n plus 1 by 3 plus 2. This becomes 2n plus 2 by 3. This 2 and this 2 will get cancelled. So you'll be left with n into n plus 1 into n plus 2. Here it will become n plus 2 by 3. Right? Here this part becomes 2n plus 1 plus 3, 2n plus 4. Then we can take 2 common, 2 into n plus 2. That 2 and this 2 we can cancel. So we'll be left with n into n plus 1 into n plus 2 by 3. So this is the final answer. This is how we have to do when there is some product, and within the product there are some known series. There are some series like arithmetic progression and all. Right. Hope you like this. Thank you guys.